In this episode, we're going to talk about a category of technology that shows up everywhere now, from offices to homes to industrial environments, and often brings risk people do not expect: connected devices and Internet of Things, IoT. These devices can include cameras, printers, conference room systems, smart TVs, badge readers, sensors, medical devices, and many more. They often have one job to do and are designed for convenience, not for strong security. They may run simplified operating systems, have limited update mechanisms, and use default settings that are easy to overlook. Beginners sometimes assume that because these devices seem small or simple, they do not matter much. In reality, they can become footholds, surveillance points, or stepping stones into more valuable systems. Our goal is to learn how to reduce risk in a practical way using 3 core strategies that scale well: isolation, updates, and monitoring. These are not magic fixes, but together they dramatically reduce the chance that connected devices become an easy attack path. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with why connected devices are risky. Many IoT devices have long lifespans and are deployed by facilities teams, contractors, or business units rather than security teams. That means security review may be minimal. Devices might ship with default passwords, weak authentication options, or unnecessary services enabled. Some devices communicate with vendor cloud services, creating external connections that may be hard to audit. Others are installed and forgotten, running old firmware for years. Attackers like these devices because they are often poorly monitored and because organizations may not even know how many they have. If you do not know a device exists, you cannot update it, isolate it, or watch it. So risk reduction begins with the simplest step. Treat connected devices as real computers on your network with real attack potential, not as harmless appliances. Isolation is often the most effective first control because it reduces the blast radius even when devices are imperfect. Isolation means placing devices on restricted network segments so they cannot freely communicate with everything else. In a flat network, a compromised camera might be able to reach servers, user workstations, and sensitive systems. With isolation, the camera might only be able to communicate with the specific management system it needs and the vendor service it is designed to contact. Isolation can also mean controlling which devices can talk to each other, limiting lateral movement opportunities. For beginners, the key idea is that isolation assumes compromise is possible. You are designing the network so that if a device is compromised, it cannot easily become a bridge into critical areas. This aligns with defense in-depth thinking. You do not rely on the device to be perfectly secure. You rely on the environment to limit what the device can do. Isolation works best when it is intentional and based on device function. Many IoT devices only need to talk to a small set of destinations. A badge reader might need to talk to an access control server. A printer might need to talk to print servers and directory services. A sensor might need to send data to a monitoring platform. If you understand these legitimate communication needs, you can restrict everything else. This restriction is powerful because it makes abnormal behavior more visible. If a device is isolated and then you see it trying to connect to many internal systems, that is a strong signal of compromise or misconfiguration. Isolation also reduces the chance that one compromised device can scan the environment widely. Beginners can think of isolation like putting unfamiliar visitors in a waiting room rather than letting them wander the building. They can still perform their intended function, but they cannot roam freely. Now let's talk about updates, which often sound simple, but are tricky in IoT. Updates include firmware updates, software patches, and configuration updates that close vulnerabilities. Many devices have limited update options, unclear support lifecycles, or require manual intervention. Some require downtime that business owners do not want. Others may break functionality if updated incorrectly. Despite these challenges, updates are essential because many IoT compromises exploit known vulnerabilities that were never patched. The risk is not always a new, advanced exploit. It is often an old weakness that persists because devices were ignored. A practical mindset is to treat firmware as the device's operating system. If you do not maintain it, you are leaving an old operating system on your network with unknown vulnerabilities. Updates are how you reduce that risk over time. A beginner-friendly approach to updates is to focus on 3 questions. First, is the device still supported by the vendor? Meaning, does the vendor provide updates? If the device is end of life, risk increases dramatically because known weaknesses will remain unpatched. Second, do you have a process for applying updates regularly, not just when something goes wrong? Third, do you know how to test updates or roll back if needed? This is not about becoming a device engineer. It is about establishing governance. Even a simple schedule for checking firmware versions and applying updates can reduce risk significantly. When updates are difficult, isolation becomes even more important because it limits exposure while you work within operational constraints. Credential hygiene is closely tied to updates because many devices ship with default credentials or weak authentication. While not the main headline of this lesson, it is so common that it is worth reinforcing. Changing default passwords, disabling unnecessary accounts, and using strong authentication options when available are basic steps that prevent easy compromise. Many attackers begin by trying default credentials. If those succeed, the device is compromised without any advanced skill. In cloud and SaaS, you learned about identity and guardrails. In IoT, identity is often simpler, but the principle is the same. Access controls must be intentional. When devices support unique credentials and centralized authentication, using those features reduces risk. When they do not, isolation and monitoring become even more crucial because compromise may be easier. Monitoring is the third core strategy, and it is what keeps you from being surprised. Monitoring means observing device behavior and detecting when it deviates from what is expected. Because many IoT devices have predictable communication patterns, monitoring can be very effective. A camera might normally communicate with a recording server and a vendor service. A thermostat might normally communicate with a controller and occasionally with a cloud endpoint. If monitoring shows the device suddenly scanning other internal systems, making repeated outbound connections to unfamiliar destinations, or transmitting unusual volumes of data, that is a red flag. Monitoring also includes watching for device availability changes. If a device suddenly goes offline, that might be a maintenance event, but it could also indicate tampering. The beginner lesson is that you do not need perfect monitoring of everything. You need enough monitoring to notice meaningful changes in behavior for devices that should be relatively stable. There are different layers of monitoring, and understanding them helps you reason about coverage. Network monitoring can show you where devices communicate and how much data they send. Endpoint-style monitoring is often limited for IoT because you may not be able to install agents. Therefore, network visibility becomes especially important. Asset inventory is also a form of monitoring because it tells you what devices exist and where they are. If your inventory is inaccurate, you may miss devices that are vulnerable or compromised. Log collection from device management platforms can also provide clues, such as configuration changes or authentication events. A SIM can tie these signals together, correlating a device's network behavior with changes in its configuration or identity usage. For beginners, the key is to remember that monitoring is not just about catching attackers. It is also about validating that your isolation and update strategies are working as intended. At scale, meaning when you have many connected devices, you need repeatable rules rather than handcrafted attention for each one. This is where standard categories help. Devices can be grouped by function, and each group can have a baseline policy for network access, update cadence, and monitoring thresholds. For example, cameras might have one set of isolation rules, printers another, and sensors another. This grouping reduces complexity and makes it easier to detect anomalies. If a printer suddenly behaves like a server, that is suspicious. If a camera begins communicating with internal database systems, that is suspicious. Group-based baselines also help with response. If a category of devices is known to be vulnerable, you can prioritize isolation and updates across that category rather than reacting device by device. Beginners should see this as the same principle used in other areas of security. Standardization and policy reduce human error and increase speed. It is also important to connect IoT risk to post-exploitation concepts you learned earlier. A compromised connected device can act as an initial foothold, especially if it is exposed to the internet or has weak credentials. From that foothold, the attacker may attempt internal discovery and lateral movement if the network is flat. They may establish C2 communication if the device can reach external destinations. They may use living off the LAN tactics by abusing built-in device features or management interfaces. They may even stage exfiltration if the device can access sensitive data flows or capture audio and video. Understanding these possibilities helps you take connected devices seriously. They are not just targets for prank attacks. They can be stepping stones into the rest of the environment, and they can also be sources of sensitive information themselves. By the end of this lesson, you should be able to explain a practical, scalable approach to reducing connected device and IoT risk. Isolation limits what devices can reach and reduces the blast radius of compromise. Updates reduce known vulnerabilities over time, and unsupported devices should be treated as higher risk. Monitoring helps you notice abnormal behavior, validate policy effectiveness, and detect compromise early. Together, these strategies create a realistic defense that does not depend on perfect device security. The decision rule to remember is this: whenever you deploy or discover a connected device, first isolate it to only what it needs, then ensure it has a sustainable update plan, and finally monitor its network behavior for deviations from its normal, predictable communication patterns.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.